Okay, so S1 chapter 7. This is the last chapter in S1. Normal distribution, and I've adapted one of Dr. Frost's PowerPoints, so thank you very much. So, what is the normal distribution? So, it's following a probability distribution, and what we find is if we were to plot the average height of males in this room, okay, we would find that roughly the mean height would be 180, okay, and this is a normal distribution. It's symmetrical about the mean. This is the mean, 180. And what we normally find is, this is called a bell curve, okay, because it's symmetrical about the mean. And we're going to find that we're going to have more people with the height centralised about the mean, aren't we? We're not really going to have people go, this isn't going to be all the way up to 500 centimetres, is it? Okay, and this isn't going to be all the way down to 0 centimetres. So it's going to be roughly in between a set amount. Of course, we may have a few outliers, as you know. So what we're going to have a look at is different types of normal distribution curves and how they, and what they look like. So normally what we have is, when we have our normal distribution curve, this is centred about the mean, and this only works for continuous data. So, for example, our normal distribution is going to look like this, okay? And our standard normal distribution curve is going to be with Z. Our maximum point on the curve, like the middle, where it's about symmetry, we're going to call this 0, but this is actually going to be our mean. Now, another notation for mean is this, and we call this mu. Okay? So this is our mean. And typically, we are 3 standard deviations above and below the mean. Now, they did a lot of research about this. Now, we know one standard deviation, we know a standard deviation. This is the symbol we've been using, sigma, for standard deviation. And we know that variance is a standard deviation squared, isn't it? Okay? So understanding this curve is really important, because this is how we get information from the table. So first of all, the centralised point is always about the mean. For a standard normal distribution, we have up to 3 standard deviations above the mean and 3 standard deviations below the mean, okay? So, a few fun facts. Fact number 1. Now, this is done from research, loads of research, and this is how they've got the tables, okay? When we have this data, if we are between 3 standard deviations above the mean or below the mean, okay, all of this covers 99.8% of the data. So remember what we're looking at probability, so we have to think the area under the whole of this graph adds up to 1, okay? But if we were to do 3 standard deviations above or below the mean, the fact is 99.8% of the data is here. If we were to do standard deviations of 2 above the mean and 2 below the mean, like this actually covers 95% of the data. Okay? So these are just some facts that you need to know. Now, what else do we need to know? We need to know that Yeah. Everything that we're going to do today, I'm going to draw a diagram for us to help understand, okay? But you've got to remember that all of the area under the graph adds to 1, because as we know, probabilities add up to 1. So when we're looking at the probabilities, this will make sense. Okay, so for a normal distribution to be used, the data has to be continuous. We can only use this on continuous data. With a discrete variable, all the probabilities have to add up to 1, okay? And for a continuous variable, the area under the probability graph has to add up to 1, which we've just said. The area has to be 1, or 100%, okay? And then to find the probability, for example, of P, the probability of our variable x being in between 117 and 119, we would literally just find the area of the orange bit. Okay, we find the area of our x being in between 170 and 119. And if we ever wanted to find the probability of x being 200, for them to be exactly 200, you know, because they might be 199.4, you know, 200.6. To be exactly 200 is like really infinitely small. So we wouldn't look at it as a probability. We would look mainly at finding probabilities of a value being less than, or probabilities of a value being more than, or probabilities of a value being in between them when we're looking at the normal distribution, rather than being exactly a specific number. Now, because this graph is symmetrical, if we ever wanted to find the probability of our function being less than mu, okay, so this is our function being less than the mean. Now, we know because it's symmetrical that 50% is on the left-hand side of the mean, and 50% is on the right-hand side of the mean. Okay, so it is symmetrical. We have to remember this fact. So, notation is the random variable x is distributed. So this lovely line means is distributed. Okay? This n means using the normal distribution. If you do further maths and you do S2, what you might have, instead of an n here, they'd put a big capital B. That means with the binomial distribution, okay? Now, luckily for you, we're just dealing with the normal distribution. And the reason why we have this is because this tells us which table we will be using. Like if I had a B, we'd find the table with the binomial distribution. We have an n, we're looking for the normal distribution. Now, lucky for you, I've already printed it. And then it says using a normal distribution with a mean of mu and a variance of sigma squared. Now we know sigma is our standard deviation, okay? Now this notation might seem a little bit scary, but it really isn't. All we have to do here is, this is an example. X represents the height of a randomly chosen person with the mean 160 and standard deviation 10. So if we were to write this in notation form, we know if we're looking at height, we know this is continuous. Now, lucky for you, you're only going to be doing the normal distribution. So it's really simple. You're just going to write the random variable x is distributed with the normal distribution with a mean of 160 and a standard deviation 10. So this becomes 10 squared because remember we want the variance. Okay? And this is it. Done. So this means that x is normally distributed with a mean 160 and a variance of 100. Now, either way is completely correct. Now, the reason why we need to be able to write it into this notation is because what they've done is we're not going to draw the normal distribution specifically each time for specific sets of data. we're going to use the standard normal distribution, because what they've done is they've been able to map any distribution onto the standard normal distribution by using a code, which we will come to later. So, the Z value, which is what we're going to find out now, is the number of standard deviations a value is above the mean. Okay, for example, and this is for example, what this means is we normally go about 3 standard deviations above the mean. So if this is 100, our standard deviation is 15. Okay, now each gap is 1 standard deviation. So 100 plus 15 is 115. Another standard deviation, 130. Another standard deviation, 145. The same going backwards. It's 1 standard deviation. It's told us a standard deviation is 15. So this is going to be 85. Again, if I take away, this is going to be 70. And then 55, okay? So this never changes. Each gap is always 1 standard deviation. So, what this is saying is, this says, let X be normally distributed, be distributed with a normal distribution with a mean of 100 and a variance of 15 squared, okay? So, if this is our IQ of different people, what is our Z value? Now, if it's 100, our Z value, how many standard deviations is this away from the mean? 0, absolutely. Because we know this is 0. And remember, when we looked at our normal distributed table, this was our standard deviations. So 130, how many standard deviations is this away from the mean? 2. Yeah, it's 2 above the mean. 85 minus 1. 165. Whoa. 165. Well, we could keep going. This would be what? 160? 175. Okay, we could technically keep going. Okay? And if I was to do 165, I know that this is 1 standard deviation, 2 standard deviations, 3 standard deviations, 4 standard deviations, and 65, between 160 and 75 is 15. So 5 would be a third. So this would be 4.3. This is just a bit of fun. This is just so that I just need to know that you can understand. Okay? How about 62.5? Where would 62.5 be? It'd be minus 1, minus 2, and it is exactly in the middle between 55 and 70, so it'd be minus 2.5. Okay, so this is just understanding. Okay? We normally will only look at 3 standard deviations above or below the mean, but this is just seeing if you can understand what's going on. So now what we're going to look at is looking at the Z table. So here we go. Here is the Z table. Now, using the same table that we've just done, we had the IQ here. We knew that 130 is where Z equals 2. Okay? Finding the probability of Z being less than 2, we need to use the normal distribution table. Okay? Now, in this, it's really important to know that the probabilities on this are always calculated by any probability you find in the Z table is found by doing the probability of Z being less than our little value of z, okay? So using our table, it says here the probability of z being less than 2. So we want to find the probability that you are less than 2 standard deviations away, positive, 2 standard positive deviations away, okay? Now, as you can see, this means we want the whole of this area. First of all, using our intelligence, we're expecting this to be over 50%, okay? Now, we also know from our fun facts earlier that in between 2 standard deviations above or below the mean, so here and here, in between there, we know that's 95%. Okay, so using our mathematical knowledge and common sense, we know our number has to be above 95%. But lucky for us, after years of research, they've done it in a table. You literally go onto your table, find Z that says 2, okay? And 0.9772 is the answer. That's it. Really simple. Really simple. Okay? This is really simple, but this is where really understanding the graph is crucial. For example, if it wanted the probability of z being greater than 2, what we actually want, we know probabilities add up to 1. So this is 1 minus the probability of z being less than 2. Because if you think about it, if we want greater than 2, we just want this section. Now, our table doesn't tell us that, so we get creative. If we know all the area under the curve adds to 1, we want the right part of that tail. If we know from that point all the way to the left is 0.977, how am I going to find the other bit? I just do 1 minus. Okay? So, which is going to give me 1 minus 0.9772, which is 0.0228. And that is that little probability. And if you think about it, that makes sense, because if you think about the majority, and always make sure, does this make sense in your head? Okay? So now we're going to use, now we're going to practice using the Z table, okay? Now, step 1, when in doubt, draw it out, okay? So, this one's, if you can see here, we want Z is greater than, so we want Z is greater than this. Now, the table only gives us less than. So, what am I going to have to do? I'm going to have to find the probability of Z being less than minus 0.3 and do 1 minus, okay? Sounds plausible, right? So I would find the probability of this part here, which we know is the probability of Z being less than minus 0.3. Remember, the table only tells us less than. And then I would do 1 minus this to find the answer. Slight issue. There is no negatives, okay? So even though this is completely right thinking, and we need this thinking, we need everyone to be able to understand this thinking, this is not correct for this example because we don't have a negative. But still, well done. You'll get to this and you'll think, no, I don't have it. Okay. What else do we know? We know that this curve is symmetrical. So actually, finding where our z is less than 0.3 is going to give us the exact same area, because that chunk to the right is going to be the same as this chunk here on the left. Okay? Because they're symmetrical. So all we're going to do now is when it's a negative, we can actually just say we want to find the probability of z being less than 0.3 because it's symmetrical about mu, which is our mean. So I'm going to look at my table, 0.3, which is 0.6179. Perfect. Okay. Number 2. We want the probability of z being less than minus 0.03. So we want this little chunk. This we know. We already figured out what is greater than 0.3. So 1 minus. So we actually need to do 1 minus the probability of z being less than 0.3, because that's how we find the actual value off the table if we were to do this without doing part A, which we know is 1 minus 0.6179, which is 0.3821. Okay, the next one, and what's the probability of z being greater than 1? So what are we going to do? Okay, the table only gives us less than. So if it says greater than, we know we've got to do something different. This is the same as finding 1 minus this bit, isn't it? 1 minus that whole chunk. So we can do 1 minus the probability of z being less than 1, which is 1 minus 0.8413, which is 0.1587. Okay? Now, again, we have a negative here. It is a less than, so we know we can find it, but it's a negative. So we're going to flip it to do the symmetry. So we're actually going to find it where it's 2, aren't we? But remember, we want this part. So we're going to have to do 1 minus the probability of z being less than 2, okay? And which is 1 minus 0.9772, which is 0.0228. Right, so test your understanding. I would suggest, if you're not sure, draw a picture. Okay, when in doubt, draw it out. So, feel free to discuss these. Okay, for the first one, we want z is greater than 0.7, okay? So what we want is, if this is 0.7, we want z is greater than. Okay, straight away, we want to the right. Can we figure out what it is to the right? Nope. So we need to do 1 minus probability of z being less than 0.7, and we should have got 0.2420. Okay, the next one, we want z is less than minus 1.25. So we want here. Now we can figure out what's to the left. But the problem is that it's a negative number. And do we have the negative one? No. So this is the only problem, when what we're trying to find is negative. So actually what we can do, because we know it's symmetrical, is this is the same as finding the probability of it being greater than the positive of that value. Okay? So this is z being greater than 1.25, which we know is 1 minus the probability of z being less than 1.25, which is in fact 0.1056. And then the last one, we want the probability of z being greater than, so we want this part here. Okay? Now, being greater than, we can't do, and it's also a negative, but we know using symmetry that actually this is the same as finding it being less than that number. So in this case, we don't need to do a 1 minus. We just need to find the probability of our z value being less than 2.42, which is 0.9922. Because if you think about it, and this is where common sense comes in, how much of the curve is shaded? A really big amount. Okay? Yeah, we're expecting this to be close to 1. If you got 0.1 something, or 0.0 something, come on. Really think. Okay, so now what I said earlier is the reason we can do this is because what some amazing mathematicians, well, statisticians, which are mathematicians, did was they devised a way where any distribution modelled by x can be transformed onto the standard normal distribution, which we use z for. Okay, so it's by they've been able to map any values onto a z1. So it doesn't matter if we're looking at height of 180 is our mean. We can use coding to map that onto our standard normal distribution and be able to find the z values using coding. So, for example, do you remember earlier we had with the IQ, we had that mu was 100 and sigma was 15, okay? And I don't know if anyone remembers, but this was actually free. Yeah, because this is 3 standard deviations away from the mean. Well, in Z world, you're right, this is free. Okay? But we know this because we sat there and we worked it out. We added 15 each time, didn't we? And we know this. We can't be doing this all the time. And there is an answer. There is a formula. So the formula is our variable of x minus mu divided by sigma. Okay? So it's x minus the mean divided by the standard deviation. Really, really easy and simple formula. So I'm going to show you how this looks, okay? And why we need this. So here's an example. Now we've already done the first part of this example earlier. So normally what would happen is you'd be given a worded sentence. For example, the heights in a population are normally distributed with mean 160 and standard deviation 10. Find the probability of a randomly chosen person having a height less than 180. Okay? So we already did this part earlier. Don't get any marks for that. But it's really good practice to write it. The second part, we want the probability of our height being less than 180. Okay, this is great. I have essentially I have our correct notation in our question. But how is this going to help me on my Z table? It's not until we use standardization. So with the standardization, we know that to find our Z value, to find the probability of x being less than 180, this is the probability of z being less than. Now remember, we need to do our variable, which is 180, minus the mean, which is 160, divided by our standard deviation, which is 10. So what we're actually finding is the probability of our z value being 20 divided by 2, less than 2. Now, don't just get all ahead of yourself and start looking on the z table for the value of 2. First, let's check, okay? It wants z is less than 2. So actually, this is our 0, 2's roughly here, and it wants less than. Can we do that just by looking at the table? Absolutely, we can. Brilliant. So now we can look at the table, but I always want you to stop. Don't just assume. This is where people make the most mistakes, and these are actually really easy questions. Okay? And we have a look at 2. So we know our probability is 0.9772. Nice and simple. Okay, so test your understanding. These are part A's of questions, and you can see they're typically worth 3 marks. Off you go. Okay, so the heights of an adult female population are normally distributed with 162 centimetres, a mean, and a standard deviation. So we know we can write X is distributed with a normal distribution, with a mean of 162 and a standard deviation of 7.5. Now remember that this is when we write the notation, we're looking for the variance, okay? So let's find the probability that a randomly chosen adult female is taller than 150 centimetres. So we want the probability of X being greater than 150. Okay, now, as we know with our Z tables, we don't have an X value. So we need to use the standardisation formula to convert this into a Z value. So we want the probability of Z being greater than. Now we know it's our value X minus the mean divided by the standard deviation, 7.5. Okay, this is going to give us our probability of our Z being greater than negative 12 over 7.5, which is negative 1.6. Okay, now we're always going to stop when we see this. You know why? Because we're going to draw a picture, we're going to figure out what's going on. So, the area it wants is, here's our 0, negative 1.6 is roughly here, and we want greater than, so we want all of this area, okay? Now, lucky for us, we know there is symmetry, so actually this is the same as saying we want less than the positive value. So we want the probability of Z being less than 1.6, which is going to equal 0.9452. Nice and easy and simple, 3 marks. The time in minutes taken to fly from London to Malaga has a normal distribution with a mean of 150 and a standard deviation of 10. Find the probability that the next flight from London to Malaga is less than 145 minutes. Okay, so to find the probability that this is less than 145 minutes, I'm going to use my standardisation. I'm going to bring it over here. So the probability of Z being less than our variable minus our mean divided by our standard deviation, which is the probability of Z being less than negative a half? Yeah. Okay, now stop what you're doing. Negative a half. Draw a picture. If I was to draw this picture, remember this is 0, okay? And it says less than negative a half. So we want this bit here. And we're in the negative zone. Okay. So if we're in a negative, to turn it to a positive, we can reflect it. And if we reflect it, we're then going to end up with this bit, aren't we? Okay, if we reflect it. But remember, we can't find to the right when it's positive because the Z value doesn't get us. It only gives us to the left. So actually, we've got to do 1 minus the probability of Z being less than 0.5. Okay? Which is going to be 0.3085. Because remember, think about this. If I only want this bit, I know that half of this is 0.5, don't I? So you know you've gone wrong if your number is bigger than 0.5. Because from here to here, our probability is 0.5. From here to here, our probability is 0.5. So you know, and this is what I was saying earlier about common sense. Okay? Okay, so the other only thing now is that sometimes it wants in between a range. Okay, so it wants the probability of 96 being less than X being less than 112. Okay? So, step 1, we need to find the Z values for both. Now this is really easy, because if you think about it, if we have it this way, how are we going to find that section? Now I always draw a picture. So, if this is 112, if I find the probability of less than 112, yeah? So the probability of x being less than 112, and I minus the probability, and I take away this probability here of x being less than 96, I'm left with this part, which is the part we wanted. Do you see? Yeah? It's just common sense. Drawing pictures is the way forward. So, step one, whenever we have a double one, you have to figure out what's going on. Sometimes it's not as easy as this, but sometimes it is. But just when in doubt, draw it out. Then what we're going to do is we're going to have our probability of x is less than 112. Well, we need to find our standardization value of z. So we know this is the probability of z being less than 112 minus, now in the question earlier it told us, 100 over 15 minus the probability of z being less than 96 minus 100 over 15. So what I'm actually going to have is the probability of z being less than 0.8 minus the probability of z being less than negative 0.266. Okay. Now, here's an issue, isn't it? Yeah? What issue do we have? Well, the first one's easy. We just want probability of z being less than 0.8, which is 0.7881 minus. Now, the probability of z being less than a negative number, can I do that? No. Now, because it wants z being less than a negative number, think about this. Okay? I want z being less than minus 0.2, which is this. Oh no. Maybe here. I want that being less than. Now, this is the same if I flip it. We want this bit, don't we? And if this is 0.266, okay, we want that bit. But to find that, yes, it's 1 minus. So then this actually becomes the probability of 1 minus the probability of z being less than 0.266. Now we have a slight issue. The issue is, on our table, how many decimal places do we go up to? 2 decimal places. Now, this is where we're going to use a calculator, okay? But I'm not going to show you that now. For today, let's just round this to 2 decimal places. 27. Okay? So I'm going to get 0.781 minus 1 lots of minus, and 0.27 is 0.6064. When I work all of this out, I'm going to get 0.3945. Now, there are formulas that you can learn for all of this, but don't do it. You're going to have enough to remember. What you need to know is to draw it out, and it is logical and common sense. Okay, so I'm not going to draw the pictures, but I am going to just write down the calculations you should have done. So for the first one, we should have done the probability of z being less than 0.5. Now we know minus the probability of z being less than 100. Now in this case, 100 is our median, isn't it? Not our median, sorry, our mean. So we don't even have to write that, because we know the value of it being less than the mean is in fact 0.5. Which equals 0.1915. For the second one, For the second one, we should have worked out our z, which is the probability of 1.53 being less than z being less than 3.4, which is the same as the probability of z being less than 3.4 minus the probability of z being less than 1.53, which is nice and easy. We just had to figure out the values. We should have got 0.0627. For the third one, we should have got the probability of minus 2 being less than z being less than minus 0.67. So, how this should, when you worked this out, we should have had the probability of z being less than minus 0.067 minus the probability of z being less than minus 2. Okay? Now, for each one of these, it is in case, because it's a negative and we want less than, we are actually doing 1 minus. So we're going to have, for this one, we're going to have 1 minus 0.7486 minus 1 minus 0.9772, which is going to give us 0.2286. What we're going to do now is we're going to find the reverse, because as you know, we've just been doing some of the simpler stuff. But sometimes it will tell us the probability, and then we've got to work out the mean or the standard deviation or the z value. Okay, so we start at one end, we're working backwards. So step one, we're just going to find some backwards. So it tells us the probability of z being less than little z. Now remember, really important, the table only tells us the probability distribution of z being less than a number, doesn't it? Yeah. So for all of these here, these are all less than, aren't they? Yeah? And so that means for the first 4, oh no, we have less than, less than, less than, less than. This is literally going to be, I'm going to look for our phi of z being 0.87. So now what we're doing is we're looking in the column that looks like this to find our z value. So we're looking for 0.87. So everyone get your sheet, let's have a look. 0.87. 1.13, absolutely. Okay, 0.92. What? Yep. We're finding the closest value. So for 0.87, 1.14 is also 0.8729, but 1.13 is 0.8708. This is the closest. Yeah? Okay, next, off we go. 1.4. So 0.92. 1.41. 0.7. 0.53. 0.85. 1.04. Absolutely. So those are nice and easy. Now, for the next one, it's slightly different. Because it wants the probability of z being greater than. Yeah, so we know to find that probability, we had to do 1 minus the probability of z being less than z. Okay? So to find z being greater than z, the probability, to find this we had to do 1 minus the probability of z being less than z equals 0.23. So that means the probability of z being less than z is 1 minus 0.23, which is 0.77. Yeah. So that means our z value, if I have a look on here, 0.77. It is 0.74. Perfect. And then for this one, we want the probability of our z value being less than z is 0.1. Try and find that for me. Okay, so by now you should be looking at the table and thinking, hold on a minute, it's not there. And that's because our smallest value is 0.5 and our largest is 1, okay? So, when we have a probability of z being less than 0.5, remember it's symmetrical, completely symmetrical. So the probability of z being less than z of 0.1 is the same as the probability of z being less than negative z of 0.9. Okay, and it's because we had to do 1 minus that actually we're now finding the negative of it. Because remember the 0.1, if that probability is less than, that means actually we've gone to the left-hand side of the mean. Okay? Because anything greater than 0.5 is to the right-hand side of the mean. And less than 0.5 probability is to the left-hand side of the mean. So this is actually going to give us a negative value. Think about this. Are you ready? Now remember, when in doubt, draw it out. So, the mean is in the middle here, okay? And up to the mean covers up to 50%. The probability of the mean is 0.5, isn't it? So up to here is 0.5. And then from here to here is 0.5 to 1, okay, in terms of probability. This is 0.5, up here is 1, this is 0. We go from left to right. So essentially, if we're going to find the probability of 0.1, this means we want to find up to here, don't we? We only want that little bit of area. Now remember, we can't do that, so essentially we'd be doing 1 minus, okay? So this value, when we're finding this is actually going to be a negative value, isn't it? So if we look at this as our standard normal distribution, this is 0, this is 1, 2, 3, this is negative 1, negative 2, negative 3, and this is then going to give us negative 2 is probably, well, it's not negative 2, but for example, negative 2, a negative number is going to give us that 0.1, okay? So what we do then is we find the value of 0.9, which is 1.29, okay? So I find 0.9 on the table, which is 1.29. And because this is what our minus z is, so our z equals negative 1.29, okay? So this is for probabilities less than 0.5. It's going to be a negative value. We still can use the table, it's symmetrical, but it's just negative. Yeah? So, let's have a look. Step 1, if it's less than and it's greater than 0.5, you can do the same as what we did with the blue, just looking at the table. If it's greater than, you're going to have to figure out what's going on. And if it's less than and less than 0.5, this is where you've got to figure out what's going on. So now, what you're going to do is you're going to spend 5 minutes. You can work in pairs, I don't mind. You need to do all of these. Remember, when in doubt, draw it out. Remember, we're working backwards. Off you go. Okay, so we're saying z is greater than something, gives us the probability of 0.86. Okay? So, essentially, if I was, if I was to draw this graph, here's our mean. Now remember, the whole of this is 1, isn't it, the area? So take yourself away from what's going on. If we just think the probability z is greater than a number is 0.86. Well, I know that this is 0.5 already, isn't it? And something greater than a number is 0.86. So I want the probability of a number being greater than 0.86. So I want the chunk on this side. So it's going to be about here. Yeah? So the probability of something being greater than this number, z, is 0.86. So you can see here I've got my probability This is 0.86. This is a half, this is 50%, and this is more than a quarter over. So it's roughly 0.86. Now, if we think about this in terms of the standard normal distribution, we know this is 0. So this must be a negative number. Okay? Now, we know that when we calculated this earlier, when we drew something like this to calculate it, what did we do? Yeah, we reflected, didn't we? And we did 1 minus. We in fact did 1 minus. No, we didn't do 1 minus. We just did the probability of it being less than the positive of that number. That gave us the same. We didn't do 1 minus, we just did the probability of whatever this was. The probability of Z being less than that. Because that's how the formula works. We can only find the probability of Z being less than a number. This is where this has come from. So this only works when the probability of Z is less than that type. Now, because we're mathematicians, we can manipulate anything we have to make it so it's less than. Does that make more sense? No? No? Okay. Right. Let's try it a different way. Okay. Are we happy that this is what the question is saying? The probability of Z being greater than, if I don't, okay, I'll tell you what, I'm going to call this A. Yeah? The probability of Z being greater than a number A is 0.86. Are you happy with this drawing? Okay. But if we're looking for a value that's less than the mean, we're saying it's less than 0. Our normal distribution table does not give us negative values of Z. We know from this graph that this is a negative value of Z. What else do we know about the normal distribution? It's symmetrical about this point. So I could reverse this, but if I flip it, if I flip this, essentially I'm multiplying it by -1. Yeah? So that means if I times it by -1, if it's a transformation, okay, our A is now here, but this is essentially negative A, isn't it? Multiplied it all by -1, and I still have 86% of my probability. So this is why the probability of Z being greater than A equaling 0.86 is the same as the probability of Z being less than the negative A equals 0.86. Now, can we do less than? Yes. It still equals 0.86. And then what we're finding is when we find the probability, we now find negative A. If I have a look on here for 0.86, I get 1.08. So negative A is 1.08. But I don't want negative A, do I? What do I want? Positive A. So how do I just multiply both sides by -1. So this equals minus 0.108. So this is saying that this value is just over 1 less standard deviation away from the mean to find this probability. Okay? Okay, so for the first one, it's nice and easy. We have the probability of Z being less than Z and our probability is over 0.5. So this is a case we just look at the table. Okay, this is just looking at the table. This one is just looking at the table. Okay, that's easy. So everyone should be happy with those, just looking at the table. And I'm going to have 1.6449. and 0.5244. Now, for the second one, first of all, it's less than, which looks easy, but isn't. The only reason why is because our probability is less than 0.5, okay? If our probability is less than 0.5, all we have to do is 1 minus if we're still finding less than. We're finding the probability of z is less than negative z of, and we do 1 minus, which is 0.54. Now I find 0.54 on here, which is 0.1. So negative z equals 0.1, so z equals negative 0.1. For the second one, again, it's less than, but it's also, our probability is less than a half. So we're going to have the probability of z being less than the negative value of z of 1 minus, which is 0.99. So negative z equals 2.3263. So z equals negative 2.3263. Now for this one, it's greater than. So we don't have to worry about the 1 minuses, okay? We can just do what we just did a second ago. The probability of z being less than negative z of 0.975 is, and then I'm just going to go for this one. Z is just negative 1.9600. Now for the last one, it's the probability of z being greater than z is 0.43. Now this one's slightly different because we just want the probability of it being greater than 0.43. So this, if we flip it, of z being less than z of 0.57. Okay? So z equals 0.18. Just to say, sorry, I just realised I've just copied this off the Dr. Frost PowerPoint, but these are, you're only going to get 2 decimal places on, it's because these have been used on a calculator. We haven't got a calculator yet, okay? So as long as your answers are very similar when rounded, okay? Okay, now we're working backwards with inequalities, okay? So for this, some of you, this may blow your mind. Don't panic. Okay, here we go. Okay, so as I was saying before, step 1, draw a diagram. So for the question, it says find the value of A such that the probability of 0 being less than or equal to Z being less than or equal to A is 0.3. So if we are to draw a suitable diagram, we think about our Z, we know 0 is going to be here, which we know is the mean, which is in the middle. And to A, which is roughly here, this area is going to be 0.3. So, does anybody remember how we are going to find this from last time? We are going to look at the probability of Z being less than A is going to equal what? So, even though we want this bit, because this is 0.3, we know this is symmetrical and all of the left-hand side is a half. A half plus 0.3 is 0.8. Thus, A is what? How do I find this? Okay, so we look in the phi of Z column, which looks like this, an I. Okay, we're looking for, in the phi of Z column, of 0.8. Now, when we look at 0.8, we have 0.7995, and we have 0.8023. Which one is closer to 0.8? Yeah, 0.7995. So then we look at the corresponding value to this, which is 0.84. And that's our value of A. So for the second part, it says find the value of B such that between minus B and B is 0.7. So if I was to draw a suitable diagram, here is minus B, here is my 0, and here is my B. Remember, we don't know what B is, but we know it's going to be symmetrical. So that means this whole area, do it in blue. This whole area is what? 0.7. This is whole area 0.7, that means each side is 0.35, which means if this is a half, and I've already shaded in 0.35, what's left? 0.15, okay, on each side. So, when I'm thinking how am I going to do this, I know that this can be simplified as what? To find this value here, I know that this must be 0.85. So I want to find the value. P of Z is less than our B, which is 0.85. So now I look for 0.85 in my phi of Z, which is 1.04. And that was really easy because the closest value I found to 0.85 is 0.8508, which is 1.04. Fantastic. Right, test your understanding. You've got 2 questions, off you go. So, find the value of E such that the probability of minus E being less than Z being less than E equals 0.9. Okay, so that means if I was to draw my lovely drawing, this is the middle, 0.9 means if I half it, it's 0.45 on each side, yeah? So this means that this gap is 0.05. So our E is 0.95. So we want to find the probability of our Z being less than E equaling 0.95 to find that value of E. So E equals 95. Ooh. 1.65, absolutely. Perfect. And remember, we're looking for the number closest to 0.95 in this column. Okay? On the sheet in front of you. So it then says, find the value of F such that the probability of F being less than Z being less than 0. If I was to draw this again, it's F is less than Z is less than 0. So we know that F is here somewhere. Okay, and what else do we know? That this is 0.4. So we know this is symmetrical, isn't it? We know that when we're finding a lower value, it's the same as finding if we flip it to find this one, we take the negative of it. Okay? And we know between 0.4 and 0.5 is 0.1, so that's the gap. So that means minus F is 0.9. So how we could write this? We could write the probability of Z being less than F equals 0.1. Now remember, if it's less than, and 0.1 is also less than 0.5. This is the same as the probability of our Z value being less than the negative of 1 minus 0.1, which is 0.9. So I find the value of 0.9, which is 1.29? No, 1.28. 1.28. So what is my value of F then? negative 1.28. Okay, now remember, think back to it. Remember, when we're looking at the standardized graph, remember in the middle is 0. On this side is negative 1, negative 2, negative 3. Are you expecting this value of f to be negative? Yeah. When in doubt, common sense. If that's not negative, you know you've gone wrong somewhere. Okay, everyone, so far we should understand what a z value is, and we know the z formula. The z formula is z equals the mean, my x value minus the mean over our standard deviation. So in this case, for this example, we're going to have 130 as our x value minus the mean, which is 100, divided by our standard deviation, which is 15. That's going to be 30 over 15, which is 2. Okay, so that's the first thing we learned last week. The next thing we learned, calculate a probability of being above or below a particular value. Okay, so find the probability that I have an IQ of above 115. So this is the probability of z being, x being greater than 115, okay? We need to know what this is in terms of z. So this is a probability of z being greater than 115 minus 100 over 15, which is the probability of z being greater than 1. Can we find out z being greater than 1? We think, yeah, remember we don't know our probability graph. If this is our 1 here, and we want z is greater than 1, yes, 1 minus, we remember our table that we've got here only tells us the probability of it being less than. So this is the same as 1 minus the probability of z being less than 1. So, table. 1 minus, what is z less than 1? So now I look for my z value of 1, which is 0.8413. 1 minus 0.8413 equals 0.1587. And really think about this. Remember, all under here is a whole 1. Exactly in the middle is half. This has got to be less than half. Common sense. Is this less than 0.5? Yeah, you know you're right. Yeah? Okay. Then what we've done is we've just calculated how to calculate a z value corresponding to a probability. For example, the probability of z being less than z is 0.58. So what do? I look on here on 0.58, and I'm looking, when I'm trying to find my z, I look at this column, which is the second column. So everyone have a look down here and look for 0.58. I get 0.20. Yeah, because I can't find 0.58. There are two values. There's 0.5793 and 0.5832. Which one is closer to 0.58? It's the first one. So the one that corresponds to that is 0.20. Next, it wants the probability of z being greater than z equals 0.22. Okay? Now, if I was to draw this as a graph, we want it greater than a value is 0.22. So what does that mean? 1 minus, which is probability of z being greater than a number is 0.22. Do I have 0.22 in my phi of z? No, so what am I going to do? 1 minus, which is 0.78. So I look on here for 0.78. I get 0.77 is my closest. The probability of z being less than z is 0.15. Okay, so this one's slightly different. Because I want it to be less than 0.15, I want this bit, don't I? Okay, when I flip it. So, first of all, I find 0.85, and then I minus it. 0.85, where is it? 1.04. Negative 1.04. And then I want the probability of z being greater than z equals 0.95. So really, I want 0.05. So I'm going to do the negative. So 0.95, where do I get to? 1.64, 1.65. They're both going to give the same one.
Do you have a minute or you
Either negative 1.64 or negative 1.65, because it's exactly in between, okay? Right, so now we're going to look at calculating a value corresponding with a probability and calculating missing values of mu and theta. Okay, see if you can retrieve the original value. Off you go, think, pair, share. Retrieving the original value. So, step one, what IQ represents to the bottom 78% of the population? As you can see, there's already a graph drawn for you. So that would always be step one. Step two, state the problem. So we want the probability of x being less than x equaling 0.78. Okay? Now, we need to standardize this value. So we know what? This is the same as the probability of z being less than z equaling 0.78. Okay? Now, how are we standardising this? How do we find our z value? Remember, we look in the column. 0.78.
So what is 0.77?
0.78. Do we find 0.77? Is the answer? Okay. So what do we get? Z equals 0.77. And we've done that by looking at the table. Okay. And then it says use the Z formula. Now the reason why we use Z formula is because we know that x minus our mean, which is 100 from the question, divided by our standard deviation, which is 15, equals 0.77. Now I just work backwards. 0.77 times 15 plus 100 is 111.55. And there is our answer. So just to double check, I'm looking for 0.77 on this side. Remember, this is our Z, this is our phi. So 0.77 is in between 0.7794 and 0.723. It's in between these two values. But which one is it closer to? 0.7794. It's closer to this. So therefore, this is the value we take of Z. So, what IQ corresponds to the bottom 90% of the population? The bottom 90% means this. Okay? So, what I have to do is, step one, state the problem. The probability of x being less than x is 0.9, because it's the bottom 90%. This is the same as the probability of z being less than z of 0.9. I now need to identify my z value by looking for 0.9 in this column. It's 1.28. So my z value equals 1.28. And now I use the formula. X minus the mean divided by the standard deviation equals 1.28. So I'm going to multiply by 15, add 100, I should get x equals 119.25. 0.224. Incredible. Okay, what IQ responds to the bottom 30% of the population? Step 1, draw your graph. So we know this is the probability of x being less than x of 0.3, which is the same as the probability of z being less than z of 0.3. Now, if you know that halfway is 0.5, roughly 0.3 is here. Okay? What is this the same as? This is the same as 0.7, but this would be 0.7, but we want this part. Okay? So it's the probability of z being less than negative z. Remember, because we've reversed it, but we have to do 1 minus 0.3 to find the answer, which is 0.7. So once we find, this is our 0.7, once we find our z value for that, we know this is the original one, and we know anything on this side is negative. Okay, but to find the opposite, we know we can flip it. So, minus z equals, if I look for 0.7, 0.53? No, 0.52. That means our positive z is minus 0.52 using our symmetry. So then we're going to have x minus 100 over 15 equals negative 0.052. So our x value is 92.143. Okay, what IQ does 80% of the population have a value more than? Okay, so we want greater than 0.8. So when we draw our graph, we want this part. So this is the probability of x being greater than x equals 0.8. So the probability of z being greater than z being 0.8. Okay? If we want this a little bit, this is the same as 1 minus probability of z being less than negative z. Is 0.8. Because we can't do 0.2. Why? Because it's less than 0.5. We don't have 0.2 on here. Okay? So that means negative z equals 0.84. So z equals negative 0.84. Okay, because remember we want this a little bit here. And if we were to put it on this side, it'd be negative 0.84. Then what? X minus 100 over 15 equals negative 0.84. So x is going to equal 87.376. Okay, there's two types of exam style questions here to test your understanding. Off you go. A packing plant fills bags of cement. The weight x kg of a bag of cement can be modelled by a normal distribution, okay, with a mean of 50 kg and a standard deviation of 2. So we know that our mean is 50 and our standard deviation is 2. Find the weight that is exceeded by 99% of the bag. So we want, the probability that x is, find the weight that is exceeded is greater than x equals 0.99. Okay, do we like, using our table, we've got then this is the probability of z being greater than z equaling 0.99. But guess what? We can't do that. Okay? Because our table isn't greater than. So we have to do the probability of z being less than negative z of 0.99. Okay? We could do 1 minus, but still 0.01 we don't have on here. So 0.99 on here is 2.32. So negative z equals 2.32. So z equals negative 2.32. So now I know that x minus the mean, 50, divided by 2 equals negative 2.32. I'm going to multiply that all out. So x is going to give me 45.32. Perfect. Okay, so we can also do this on our calculator. Step 1. Click mode. Okay, and this is one of the Class Whiz white calculators, the one I have in my hand, yeah? Step 2. Click 7. And the picture should be a normal distribution curve. Okay? Step 3. Click 3. Inverse normal. And then you have to write your area. So you can write your area in here. You know the area you want. Our area, because it says that it's exceeded, our area is 0.01. That's the area we're trying to find, isn't it? 0.01. It then asks for your standard deviation, which is 2, and it asks for mu, which is 50. If I put this in, 0.01 and 2 and then 50, the answer is 45.347 ... Okay? Past records show that the times and seconds taken to run 100 metres by children at a school could be modelled by a normal distribution with a mean of 16.12 and a standard deviation of 1.6. On sports day, the school awards certificates to the fastest 30% of children. Okay? What does this imply, the fastest 30%? That means we want the top 30, yeah? So we want the probability of x being greater than little x of 0.7. No. Yeah, the top 30%. The fastest 30% of the children are the ones that are going to be at the top 30, aren't they? Okay. So that's the probability of z being greater than z of 0.7. Now, if I did the 1 minus to get 0.3, I don't get an answer still. So if 1 minus doesn't work, probability of z being less than z of negative 0.7. Negative z equals 0.7. So first of all, I find 0.7. Which is 0.52. So negative z equals 0.52. So z equals negative 0.52. Now I know that x minus the mean divided by the standard deviation equals negative 0.52. So x is going to give me 45.347. 15.28. Okay, let's double check this onto the calculator. Mode 7, 3. Now, it wants the top 30%, so my area is still 0.3, because that's the area I'm looking for. My standard deviation is 1.6, and my mean is 16.12. I press equals, and my x value is 15.28095, I know I'm correct. So, as I said, the most important step is to draw the diagram, okay? And as you can see, I haven't drawn them for either question. That's because you guys did. So let's just have a look at this diagram. Here's our halfway mark, okay? Now, what's the top 30% of runners? So this is what I want, the top 30. If the rest of this is 0.7, I want the top 30. Now, normally, what we would do is that would mean I want the probability of Z being less than Z equaling 0.3, because that's the same as finding this section, yeah? But remember, anything less than 0.5 I can't find. So it's the same as doing the minus. Okay, so watch out for that. That's why I'm not doing the 1 minus. Because even if I do 1 minus to find 0.3, I still don't have it on here. So I have to be more creative and think, okay, so I need to find the minus value of 0.7 to find the less than. That's what's happening here. Okay? Okay, moving on. Harder reverse probability questions. So, find the value of A such that the probability of negative A is less than Z is less than negative A. Step 1, draw a picture. Okay, this equals 0.7. So, if the area is 0.7, that means I've got 0.35 here and 0.35 here. Is everyone happy with that? It's 0.35, this is 0.35. So, we need to find the value of A here. Well, this value of A, what's 0.5 plus 0.35? 0.85. So this is the same as writing the probability of Z being less than A is 0.85. Okay? Everyone happy with that? So then again, nice and easy. Magic paper, 0.85. What does my A equal? 1.04. Okay, so everyone was happy with that. Now, this is what we have to do. Are we ready? If our normal distribution, well, if X is distributed normally with a mean of 30 and a standard deviation of 5, find the value of K such that the probability of 30 being less than X is less than K equals 0.2. Right, step 1. Okay, 30 is at the bottom end of the inequality. Yeah? What does that mean? It does mean that K is greater than 30, absolutely, well done. Okay, it does mean that. But we then need to find the probability of X being less than K equaling something. Because just like we did before on the top one, it didn't matter really what our A was here. We just wanted to find this A, didn't we? Okay, it's the same thing. The probability of X being less than K equals what? Okay, so to standardize it, we know that K minus 30 divided by 5 equals, it's going to equal something, isn't it? Okay, that's what we know. Remember, this 30 came from our mean. It didn't come from here. Okay? But if I was to draw this, because this is our mean, let's really think about what's going on. And then this is K, yeah? This area is what? 0.2. So where are we? Where are we? 0.5 plus 0.2? 0.7. Okay. So this is the probability of Z being less than K equaling 0.7. So I get my magic table. I have a look at 0.7. 0.52. So K equals 0.52. That's what I'm going to put here. 0.52. To find my actual value, multiply by 5 and add 30. Therefore, our K, back in terms of our X, is 32.622. Okay? Remember, when you're doing this, and this is why, as you can see, you were giving me all of this and you were saying, right, we know this, fantastic. But when in doubt, draw it out. Thank you. Okay, moving on. We're going to be looking at quartiles and percentiles. So this time, we know when we're looking at lower quartile, lower percentiles, it's really easy. This is just terminology. The lower quartile, so first of all, our mu is 100 and our standard deviation is 15. So we want to find the lower probability of X being less than the lower quartile is, and the lower quartile equals what? A quarter. 0.25. Okay? So this is really simple. This is the probability of Z being less than Z equaling 0.25. Do we know how to find 0.25? No. Okay? So this is the same as the probability of Z being less than negative Z of 0.75. Okay? Have a look. Where is 0.75? 0.67. Yes. So negative Z equals 0.67. So Z equals negative 0.67. We need to substitute this back in. So X minus 100 over 15 equals negative 0.67. So my X equals 89.95. Nice and easy. Second one. Upper quartile. This is the probability of X being less than Q3. Okay? And what does this equal? 0.75. So this is the probability of Z being less than Z equaling 0.75. 0.75. Z equals 0.67. So to find our upper quartile, I know I've been putting X, but you're going to do this minus 100 over 15 equals 0.67. So our Q3 equals 110.05. Okay, now what you notice as well is you didn't actually have to do this because we know the mean's 100. Our lower quartile, we're taking away 10.05. So what we could have done is just do 100 plus 10.05 to find our upper quartile. Okay, but it's all right. And then lastly, the 70th percentile. So we just want the probability of X being less than the 70th percentile, which means 0.7. Have a look for 0.7. Where are we at? 0.52. So I know our Z equals 0.52. So we're going to have P70 minus 100 over 15 equals 0.52. Rearrange to find our 70th percentile, which is 107.866. Okay, you need to test your understanding. Okay, so the heights of an adult female population are normally distributed with a mean of 162 and a standard deviation of 7.5. So, if we were to write this, how would this look? This would look like X is distributed normally with a mean of 162 and a standard deviation of 7.5. Okay? It then says, Sarah is a young girl. She visits her doctor and is told that she is at 60th percentile for height. Assuming that Sarah remains at the 60th percentile, estimate her height as an adult. So, for the 60th percentile, what does that mean? We need to find our value for our Z, don't we? So, we're saying, Sarah's younger, she visits her doctor and is told that she is at the 60th percentile. Yeah, so we're saying we want the probability of our X being less than the 60th percentile. Okay? Estimate her height as an adult. Amazing. So this is the same as the probability of Z being less than a value equals 0.6. Brilliant. So using the table, we're going to look for 0.6 in the phi of Z column, which is 0.25. Okay. So our little z equals 0.25. Okay. Now that I have this, I know x minus the mean over the standard deviation is going to equal our z. So x minus 162 over 7.5 equals 0.25. Using a calculator, 0.25 times 7.5 equals plus 162. So x equals 163.875. If we just do that to one decimal place, I get 163.9. Okay, so the distances travelled to work, d kilometres, by the employees at a large company are normally distributed with d normally distributed with a mean of 30 and a standard deviation of 8. Find the probability that a randomly selected employee has a journey to work of more than 20 km. So we want the probability of our journey being more than 20 kilometres, okay? If we want more than 20 kilometres, what are we essentially saying? Okay, so if we change it into Z, so the probability of Z being greater than, so how are we going to find our Z value? We're going to have 20 minus our mean, which is 30 over 8. 20 minus 30 divided by 8, minus 1.25. Minus 1.25. Okay, now this is where, let's get our, okay, so first things first. Okay. So, Z is greater than minus 1.25. So where is minus 1.25? Roughly here, okay? And it's greater than. So we want all of this. Now, using symmetry, this is the same as, if we were to flip it, we could just say, well, it's less than the positive of the value, couldn't we? So this is the same as the probability of Z being less than 1.25. Now I have a look on my chart for 1.25 and I get 0.8944, which equals 0.8944. So that is a nice and easy 3 marks. Now the next question, part B, is also worth 3 marks and part C is worth 1. So that's A done. Part B, find the upper quartile Q3 of D. So if we're finding the upper quartile, we want to know when the probability of Z being less than our value of Z, and we know upper quartile is 0.75, yeah, 3/4. Okay, so how are we going to do that? Okay, so we look at the table, and we look at the 5Z column, and we have a look for 0.75. The closest value to 0.75 is 0.67, because that's only 0.0014 away, whereas 0.68 is 0.0017. Yeah, so just double check that. So 0.67. Okay, and therefore Z equals 0.67. Okay, now it says write down the lower quartile. So, how am I going to work out? Oh no, we haven't finished, sorry. Right, so we found our Z value. So now what are we going to do with our Z value if we're finding the upper quartile of the distance? Does anybody know? So that means that X minus the mean over 8 equals 0.67, which is 0.67 times 8 plus 30, I get 35.36. And then the last one says write down the lower quartile. Now this is only 1 mark. So if we have the upper quartile, what could we do to help us? So if you think about it, the upper quartile we found is 3/4 of the way. So we know this is 0.25, yeah? So this value of 0.67 is our upper quartile. If we use symmetry, that means to get from here to here, 0.25, this must be minus 0.67. So all we're doing is we're using the same thing, x minus 30 over 8, but it equals minus 0.67, okay? So then our x is 8 times minus 0.67, and then we're going to plus 30, so I get 24.64. Okay. So the last part of this chapter is finding the mean or the standard deviation. So I'm going to give you 2 examples. The random variable x is distributed normally with a mean of mu and a standard deviation of 3. Okay. So first of all, I know that my mean is my mean, and my standard deviation is in fact 3. Okay, so the probability of x being greater than 20 equals 0.2. So if the probability of a number being greater than 20, and we're not sure which side it's on, if it's above or below the mean, we don't know where the mean is yet. But if the probability is 0.2, we do know that it must be here, okay? Because this is 0.2, this part, isn't it? The probability of above a certain number is 0.2. So that means the probability of x being greater than 20 being 0.2 is the same as saying the probability of x being less than 20 is 0.8. And this is where we do the 1 minus, because we're looking at the probability. Okay, so if I was to standardise this, we know this is the same as the probability of z being less than a value equaling 0.8. Okay? So I now look on my z table for 0.8 to find my little value of z. 0.84. Okay, so now I know that my x, which is 20, minus my mean over my standard deviation, which is 3, equals 0.84. So this is exactly the same as what we've been doing, apart from this time we have different values missing. Rearrange this. 0.84 times 3 equals minus 20 equals multiplied by minus 1. Our mean is 17.48. Okay, 1 decimal place, 17.5. Okay, second example. The random variable x is distributed normally with a mean of 50 and a standard deviation we don't know. Okay, so given that the probability of x being less than 46 equals 2.199. Okay, so probability of x being less than the value 46 equals 0.2119. Now, if I was to think about this, the probability of x being less than a number is 0.2 something. Okay. So, it's here, 0.21. Now, this, can I find the solution? I can, but what do I have to do? I have to find this value. Okay, I have to find the negative of it. So, even though this is the probability of z being less than z equals 0.2119, because it's less than 0.5, this is the same as finding the probability of z being less than negative z is, and then 1 minus 0.2119, which is 0.7881. Okay, so now I find the z value of that. So minus z equals 0.78. What'd you get? 0.8, yeah, it's given us the exact value, hasn't it? Which is 0.8. Okay, so what does this mean? That our z is actually equal to minus 0.8. So now using our formula, 46 minus our mean of 50 over our standard deviation equals minus 0.8. So 46 minus 50 divided by negative 0.8 is going to give us our value, which is 5. So we have a standard deviation of 5. Okay? Fun fact, if your standard deviation is negative, you are wrong. Well done. So, the random variable x is distributed normally with a mean of the mean and a standard deviation of the standard deviation. Well, actually, it's the variance, sorry. But anyway, it says, given that the probability of x being greater than 35 is 0.025, and the probability of x being less than 15 is 0.1469, find the value of the mean and the value of the standard deviation. So, first thing we should be thinking, if we've got two unknowns, probably going to have to do a simultaneous equation somewhere. Okay? So we're going to start with, we've been given two equations. We're going to go as far as we can with these two equations. First equation, probability of x being greater than 35 is 0.025. If I was to draw that, okay, the probability of x being greater than a number is literally minimal. Okay, this could be the same as the probability of 1 minus that probability, isn't it? Yeah? So the probability of x being greater than 35 equals 0.025. Probability of x being less than 35 is 1 minus 0.025, which is 0.975. Now the reason we do this is because we can't find anything less than 0.5 on our table. So 0.975 is going to give me 1.96. So our z equals 1.96. So for the first equation, we know that 35 minus the mean over the standard deviation equals 1.96. Okay? So if I wanted to, I could rearrange this to get 35 minus the mean equals 1.96 multiplied by the standard deviation. So we're going to deal with the next equation. So the probability of x being less than 15 equals 0.1469. Okay, now as we can see, this number 0.1469, how is that going to help us? Doesn't really. What we can do is, this is the same as the probability of z being less than z equals 0.1469. Okay, so we're going to have to find the negative of it, because if we were to draw 0.169, it's about down here, isn't it? Okay, to find that same number, we can just do the minus of it. So that's the probability of z being less than minus z of 1 minus 0.1469, which is 0.8531. So negative z equals 1.05. So z equals negative 1.05. So now I'm going to have 15 minus the mean over standard deviation equals negative 1.05. So 15 minus the mean equals negative 1.05 times the standard deviation. Okay, so now you can solve these however you wish. Okay, I'm just going to take them away. So I'm going to have 20 equals 1.96 plus 1.05, 3.01, 20 divided by that. Okay, so my standard deviation, I'm getting 6.64 to do decimal places. And if I substitute that in, times 1.96 minus 35 multiplied by negative 1, I get 21.976. So to one decimal place, 22.0. Okay, one decimal place, 3 significant figures. Okay, so nice and simple.